In these last two examples, let's take the cube root, 16x to the ninth, y to the fifth. All right, so first let's start with the 16. And again, I like to kind of separate these as the cube root of 16, the cube root of x to the ninth, and the cube root of y to the fifth. I like to think of them separately. So the number 16, I can break that up. That's like 4 times 4. It's also 2 times 8. Hopefully you recognize 8 as a perfect cube. But I'm going to pretend like I didn't recognize it as a perfect cube, okay? Pretend I like kept going. That's 2 times 4, and this is 2 times 2. Okay. So 16 can be written as the cube root of, well, you got 4 2's there. 2 times 2 times 2 times 2. So here's another way of looking at this problem. All right. The 3 2's all together, that's 2 cubed. That can be pulled out of the radical symbol, all right? So that should become 2 cube root. There's a 2 left underneath the radical symbol. Let's do that same thing with x to the ninth, okay? So x to the ninth, that will be 9 factors of x underneath the radical. I'm actually going to go ahead and write them all down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So how many groups of 3 do I have? I've got an x cubed, and another x cubed, and another x cubed. So how many, and there's none left underneath the radical, right? So those can all pop out. I got an x, and another x, and another x. How many x's popped out of the radical altogether? 3 of them, right? So the cube root of x to the ninth becomes just x cubed because there are 3 groups of 3 x's underneath this radical. All right, let's do the same thing with y to the fifth, okay? I'm going to write all of the y's down. I got 1, 2, 3, 4, 5. 5 factors of y. Here's a group of 3. They can pop out front. So that's one group of 3 that comes out of the radical. And how many y's are left underneath the radical? That's 2 of them. Okay? So you can always write all the factors out and then look for groups of however many your index says. All right, now let's kind of reorganize these things and write all of the outside factors together. So you've got 2x cubed y. And what's left underneath the radical is the cube root of 2y squared. All right, so that's an example where we have a cube root of stuff with variables. Let's look at the cube root of negative 16. All right, so again, I think we had seen before that 16 could be written as 2 times the cube root of 2, right? The cube root of 16 simplifies that way. But what about the negative? So let's just think about that for a minute. If I did negative 2 times negative 2 times negative 2, what would I get? I would get negative 8. So that tells me that the cube root of negative 8, if I were to do the cube root of both sides here, negative 2 is the cube root of negative 8, right? Okay, so this is my thinking here. So that tells me that if I wanted to do the cube root of negative 16, you can think of that as the cube root of negative 8 times 2, right? And the cube root of negative 8 will be a negative 2. So the negative will pop out front, and you have left underneath the radical just one factor of 2.